So, to help you guys do data analysis, because it's a big part of the IA, I've made some examples here. I just realized that says trail, not trial. Some example data sheets here. These are literally random numbers, and I want to go over some of the formulas, let you guys see that, see some graph making, as well as point out some other stuff. So starting off, we have our data here. Oops, cancel. Oops. This should probably look like if this is for people who did something like X versus Y, if you're comparing two different things, this is what you would be doing. I have my trials here, up to 25 trials, as well as my conditions, which I just put as X as Y. The main thing here that probably most people do not have is in the parentheses where I put my measurements, I also put this number here, which is something called uncertainty. Uncertainty represents how uncertain your tools are. As scientists, we need to recognize that when we use things like a scale or a ruler, right, even though our measurements are assumed to be somewhat accurate, they're not perfect. For example, let's say in this case, the ruler here, I went to 1 decimal place, but because of how the ruler is, I had to be like, well, it's plus or minus 1 centimeter. So like this one, it was 0.6, but based on how accurate my measurement tool, it could be somewhere closer to 0.5 or 0.7. That's just all this represents here. You'll need this for every measurement you do. We will talk about it more later. So that's the main thing, is make sure not only do you have your measurements somewhere in the thing on top, you do not want them in your data points, because then Excel will not recognize them as numbers. You also want your uncertainty. If you want the plus or minus symbol, that's a symbol that's literally up here. You just go to insert symbol and it'll be there. I have it recently used. It's right there. Also, please ignore all the decimal points. I kept them off for a reason. So now we have our data sets. First couple things we need to calculate, and I don't need to put labels again. We need our mean, median, standard deviation, and skew. I just widen it so everything fits. Just a quick review. Mean is the average of the data set. Median is if you put all the numbers in a line from maximum to minimum to maximum. Median would be the number in the exact middle of that number sequence. Standard deviation represents how spread out the data is, and skew represents if a distribution of the data is negative skewed or positive skewed. And we'll see that in a little bit when I make the graph based on this. Luckily, the formulas for these are pretty simple. Mean, another word for mean is average. So you just put average equals average, highlight the numbers. Same with equals median, highlight the same numbers. And then for standard deviation, do stdev. We're going to do p. There's just mildly different models for .p and .s. And for skew, it's the same thing. Equals skew, equals, and then, skew, highlight the numbers. And luckily, based on how you show your data, you can click and drag the box here. You can't click here, you have to click the box, and the formula will go across the row. So, right, it's doing the average of B2 to B26 here. Drag it across, Excel realizes I want to do the same thing. So I'll just, wrong button. I will just move those over. Just clicking and dragging from the box. I don't have to copy the formula again, or messing that up apparently. Right, and there's our kind of basic numerical analysis done. Right, we have mean, median, standard deviation, and skew. Last thing you'll need to do that is not graphing, does require some formulas, is a distribution graph. This basically shows, this is a graph, this will eventually show a graph that shows where your data is spread out, which relates to our skew, our standard deviation, all that. How to do that is you just pick ranges for your data. For here, I just pick things like that. Starting from the minimum to the maximum. If you need to figure out what those are, you can do the formula equal max, highlight your data. I'll tell you what the maximum number is. In this case, it's 2.0. You can also do the same thing with min if you don't know what your minimum, maximum data points are. Once you have your minimum and max, just break them into even groups. The number of groups and how big they are kind of up to you, but generally you should probably aim for like 5 to 10. I'm a little bit under that, but And what you want here is you want a count of each data set that is in that range. You can kind of graph and show generally where things are. How you do that is the equal count ifs function. What this function does is you tell it ranges and what you want to search for, and it will count the number of things in those ranges that meet that criteria. For this, I'm going to do the count x that are between 0.1 and 0.5. So I'll highlight all of my data x. The first criteria, because I have to break this part, is I want it to be parentheses. You have to put parentheses, otherwise it works. I want it to be greater than 0.1. Range 2 now, same range, because I want to count the same thing. And I want it to be less than 0.5. Yep. Right. Actually, just to be sure, I don't actually leave out 0.5. I'm going to do less than 0.51 and less than 0.09. Right. That tells me there are 6 numbers in x that are bigger than 0.0.9 and less than 0.51. I think you can also put equal that. Then we'll repeat that same thing for x, the rest of the thing. So count ifs, range. Criteria 1 is less than 0.52. Same thing. Same range. Second criteria is greater than 0.52, less than 1.09. Right, same thing. Gives us count there. Just repeat that each range you set up. Unfortunately, usually there's probably a way you can do this where you can just set it up with Excel, do it, but because there are two criteria you need, it's a little bit difficult. It's probably just easier to type it in manually. So I want something that's greater than 9. Range. Something that's less than that. While also being less than 1. Luckily, once we get this first round of counts done, Excel can figure out the rest for us because of how we set up our data. Let's see, criteria 1, it needs to be quotes less than 1 point. Now I want it to be greater than 1.59. The way we hit the things that are exactly 1.6. Highlight again. I want it to be less than 2.1. That should hit us. And there is our distribution. We got 14.23. Oh, we're missing some. Sorry. Let's see, 14, 2023. To somehow, but the formula should work. This is one of those things you'd have to kind of workshop after everything is done and figure out where the error was. But I'm just showing you as an example, so I don't need to figure that out. Same thing, once you do the formulas, since your rows are next to each other, you can drag your formula, run row across, and it will take the same thing, but now in C. And you have that. Okay, so before I go on to some other stuff, which I'll probably have to do in a separate video. I'll show you guys how to make graphs for this. We've done this before, so this should kind of be familiar. But what you want to do, so I have that there, is because of the way Excel works, you have to do this a little bit more manually. You want to go to Insert right here, and then you want to insert a bar graph because you're going to compare the two means. Now that you have your bar graph set up, you need to select data. Add here, the series name is X. The series value is the mean of X. Or if you think, or if the skew is high, like above 1, you might want to do the median instead. But it is up to you as a scientist. Add the second one, series name is Y. Series mean value is the mean of Y. And their skew is not quite big enough that we need to add the mean instead. So right, here's our basic graph. It needs a title and stuff like that. But data-wise, the main thing you need to add still is the standard deviation. The standard deviation represents that, hey, even though our means are this, there's this variation in the data because there's a big difference between these bar graphs with very small standard deviations and very big ones. So how you do that is you'll either go click on the chart, click add, go to error bars, click the button here and go to more options. I'll ask you for series. Let's start with X. Okay. So we want both sides. We'll have a cap. And instead of fixed value or anything like this, we'll go to custom and specify value. Positive error value is the standard deviation. Negative error value is the standard deviation, and click OK. Right, so there's our bar, but here's a standard deviation that says, hey, there's this much variation in the data, so the mean can kind of be anywhere between there, but it's most likely here. Then we'll do the same thing again. Go to plus, error bars, more options, click Y this time. Same thing. Both cap, and then we'll go to custom, specify value. Positive error is our standard deviation. Negative error is our standard deviation for Y, and click OK. Right, this is your data setup. Now just, you need titles, chart title, legend, that type of stuff. But there is your kind of data analysis chart done that shows comparison of the means of your two values. So the second graph you need to make is the count graph. Hopefully Excel's smart enough. We can just highlight this, click insert, and it will kind of put it in there for you. Kind of. Oh, yeah, well, cool. Just trying to see if there's one that makes it a little bit more bell curve looking. Okay, so right here we have our count graph where it has the ranges and then the count numerically of each one. So you can kind of see where the data is distributed. If you want to make it look a little bit cooler, you can put a trend line. I think 2-period moving average. No, probably go through the trend line and basically kind of get that bell curve looking thing. Let's do type X. Data. Let's see, polynomial, logarithmic, linear, exponential. Looks like polynomial is the best in terms of like getting that little kind of bell curve looking thing. Yeah, polynomial is the best. Again, part of this process is just playing around with the options in Excel, getting with the program. Let's see more options. Yep, so on the same trend line. Let's do count Y. Okay, and then our data for at Y is kind of weird. And then you kind of get an idea of the general pattern of that. Again, and this is our distribution graph that shows where the data is distributed. For example, in X, the data is distributed more to the left, while on Y, it has a heavy skew to the right. The last thing you might want to add onto the graph here is the median. So X, Y, and then just copy medians. Because that can be a useful thing to see on a graph like this. Is that where the median is? Oh, button. Let's see. And this will be a select data. That was the wrong button. So this will be a select data thing. Add median X value. Okay. I will look up that later because that is not the most essential thing on this graph for now. That's kind of the graphs you want. When I go to data set, we calculate mean, median, standard deviation, skew, as well as found a count so we can see our distribution of data. For this type of thing, you want just to graph the two medians along with a standard deviation error bar, and then graph the count, and then put a kind of a trend line that shows the general pattern of the count. Last thing I'll do, which I can't show you because I clicked the wrong option when I started recording, is how to find p-value from this. Basically, you will look up a t-test calculator. There are several free online. I think the one that people most have been using is the one from GraphPad. A site that's source because you're using it. And then from there, you'll plug in your data. In the columns here, you'll click, you'll figure out if you are paired, unpaired. The main difference there is unpaired assumes that the two variables don't affect each other. So this would be like if you had two just separate things going. Paired assumes that they would affect each other. So if you're working with like a choice chamber, you definitely want to use paired because where one is, it affects the other. You'll calculate, they'll give you a t-value, a p-value, all that. You want to screenshot result screen, and that should be enough to get you all your sets done. So I'm gonna start recording for now, upload this. Hopefully this used resource. Again, main things here I think most people need is uncertainty, the charts, and the count. But other than that, I think most people have these done.